Okay, so we have two objectives today. One, we want to do a proof of another trigonometric function and its derivative, and then we want to look at some very important trigonometric limits. And I'll kind of end the trig stuff for a little bit here. We'll see some more in the next section, but yeah, some good practice. Prove that the derivative, d over dx means derivative. Derivative of cosecant is equal to negative cosecant of x cotangent of x. Now, the other day we proved one. Do you remember what the derivative of sine is? Derivative of sine is cosine. And we proved that using the sandwich theorem. Remember, we took up a whole sheet of paper and we took about the whole hour? I mean, that was a very complicated proof, wasn't it? We're going to use the fact that the derivative of sine is cosine in order to show that the derivative of cosecant is negative cosecant of x cotangent of x. And what we're going to use is we're going to use the quotient rule, because I'm going to rewrite this. We're going to find that the derivative of 1 over sine of x is equal to negative cosecant of x cotangent of x. So in order to do this proof, I'm going to use the fact that the derivative of sine is cosine. And the second thing I'm going to use the quotient rule. So let's use the quotient rule to take the derivative of 1 over sine. Quotient rule says the derivative of the top, which is 0 times the bottom minus the derivative of the bottom, cosine of x, times the top left alone, just 1. All divided by the bottom squared. Yeah? Okay. What does the top become? Negative cosine of x divided by sine squared of x. Good work. The derivative of sine is positive cosine. Cosecant, we rewrote cosecant to be 1 over sine. And now we're using the quotient rule. Okay. All right. Now, the thing is, we know the answer. The answer is negative cosecant cotangent. Right? We got to make this look like this. So let's think about it. What is negative cosecant? How can you rewrite it in terms of sine? Negative 1 over sine. How can you rewrite cotangent in terms of sine? Cosine over sine, right? Do you have a cosine in the numerator? Do you have a sine in the denominator? Yeah. Do you have a negative 1 in the numerator? Do you have a sine in the denominator? Yeah, so I'm going to rewrite this to kind of split things up a little bit. We'll say it's negative 1 over sine of x times cosine of x over sine of x. What did you say negative 1 over sine was? Negative cosecant of x. And what did you say cosine over sine was? And is that what we wanted? Yep, so I'm done. It's Latin for that which was to be proved has been demonstrated. You want to do D&E does not exist? Nope. So, what's that? Done? Yeah, sure, right? Done. Done. I thought you said D&E. I was like, no, you cannot write does not exist. That's for limits. So, okay. No. Okay, now let's move on. Okay, so you're going to have to do a proof or two like that. And it says important limits of trigonometric functions. So we're going to bring up that which we did last week. Do you remember what the limit is? Theta goes to 0 of sine of theta over theta is 1. Very good. We proved that last week using the sandwich theorem. Now, there's something else that we can say that's the same as the limit as u goes to 0 of sine of u over u. Meaning whatever we're taking the sine of, if we have the same thing on the bottom, then the limit is 1. Remember what the other important limit was? 0. Very good. Those are two limits that you have to memorize. You'll be asked those questions in the AP exam. You'll be asked them on your test. You'll be asked on your final exam as well. So memorize those and feel good about it. Now, it's interesting because if you plug in 0, you get 0 over 0. And if you plug in 0 here, you also get 0 over 0. So 0 over 0 might be 1, it might be 0, it might be infinity, it might be 2, who knows? You got to find ways to work through it. So different topic for different time. Right now it says evaluate the following limits. Limit as theta goes to 0 of sine of 2 theta over theta. So I have a 2 theta there, and I can't really mess around with that. What do I want to have in the denominator? A 2 theta. I just got a 1 theta. So I'm going to multiply, because if there was a 2 theta, then what would the limit be? 1. So I'm going to get a 2 in the denominator. And we do that by multiplying the numerator by 2 and the denominator by 2. Oh, that was a bad 2. And if I do that, I get the limit as theta goes to 0 of 2 sine of 2 theta over 2 theta, right? Or you could think of it like this. The limit as theta goes to 0 of 2 times the sine of 2 theta over 2 theta. What is this limit? 1. This is 2. Question? No. All right, B. I've got a sine of 3 theta over 5 theta. Again, try plugging in 0. We get 0 over 0. So we got to do something tricky here. What do you want in the bottom instead of that 5? You want a 3. So I'm going to multiply the top by 3 and the bottom by 3. Why can't I just do that? This is 1. And 1 doesn't change the value, so then we multiply it. So multiplication is commutative, right? Meaning we can move multiplication around and it doesn't change value. So I can simply exchange this 3 and this 5, can't I? So I have the limit as theta goes to 0. I'm going to put a 3 where the 5 is and a 5 where the 3 is. So I have the sine of 3 theta over 3 theta times 3 over 5. I simply exchanged the 3 and the 5 in their location. What's this limit? 1 times 3/5 is 3/5. What's different about C? A sign in the bottom. And it's interesting to note that these work out that the limit as theta goes to 0 of theta over sine of theta is also equal to 1. That the reciprocal values work out as well. Okay. So I have the limit as theta goes to 0 of, I'm going to write cosine of theta minus 1 over 1 times 1 over the sine of theta. I'm going to split them up. Now you recognize this, right? This right here comes from this, right? Only what do we have in this example that we do not have right here? We don't have a theta in the denominator. And here we need a theta in the, so I'm going to multiply by theta over theta. And I get the limit as theta goes to 0 of cosine of theta minus 1 over theta. So I'll take that theta and bring it here. I'll bring this theta here. Cosine of theta minus 1 over theta. 0 times 0. And our last example, D, we have the limit is x goes to 0. Instead of cotangent, change it to tangent. Tangent of 5x over cosine of 2x. Okay. Because I wrote the problem forward. Now, here's what some people might do in this example. Might say the limit as x goes to 0 of, how can you rewrite tangent in terms of sine and cosine? So tangent of 5x is equal to the sine of 5x over cosine of 5x, right? Over cosine of 2x over 1, right? And so some people might rewrite it like that and then multiply by the reciprocal and try to get a 5x in the denominator, stuff like that. Good. Okay. You don't have to do that. Anybody see why? What is 5 times 0? So you get the tangent of 0 over, what's 2 times 0? 0. So you get the tangent of 0 over the cosine. Oh. Get tangent of 0 over cosine of 0. What's the tangent of 0? 0. What's cosine of 0? 1. What's 0 over 1? So sometimes, the problems might trick you out and say, well, you think that you have to apply some tricky substitution piece, when the fact of the matter is all you got to do is plug it in. If you get 0 over 0, then you got a problem. But here we didn't get 0 over 0. We got 0 over 1. It's no big deal. Okay. So the other day, I gave you a book page that you've been working on. And so we are basically done with section 3.5 now. What I would like you to do is I would like you to, from 3.5, page 174, I have two proof problems, problems 18 and 19. And then I have the 12 limit problems on the board. Now, some people wrote these down, but most everybody just took a picture of them and then used them from there. I apologize. I will make an answer key on a worksheet for these, and I will put it online as well so you can see what they are. Again, we just, no copiers really were working this morning. There was one, but I made my other copies and ran out of time. So that's what we got. Again, I know you guys got lots of work to do. I'm not trying to fill your life with stuff that isn't meaningful. But I will say in years past, people have not understood this section very well. And so I've changed the assignment to these problems instead of the ones in your book. And hopefully that helps us more.